All right. Introduction to precipitation. Now, we only get to spend a couple of lessons on precipitation. It's pretty quick, but it's one of my favourites, I reckon. I quite like it. Anyway, so precipitate is a solid that forms in your solution. So if you put a couple of solutions in together and a solid appears, then we have a precipitate, don't we? So what we're going to do is we're going to learn which ionic substances are soluble and will dissolve, and which ionic substances are insoluble and will form a precipitate or just won't dissolve. All right, now why are some ionic substances soluble and some insoluble?
Science.
Yeah. Now, it is to do with how strong the bonding is within that ionic lattice, okay? If the bonding is really strong, then they're going to stay together in the solid form and they're not going to loosen up into ions with the water, okay? What? If the bonding is not so strong, like in salt, which is sodium chloride, isn't it?
Yes.
And you put the sodium chloride in the water, then it loosens, and they go on their merry ways. The sodium ion floats around in the water, and the chloride ion floats around in the water. So they separate, and you just have the ions in the water. Okay, they're not really bonded together anymore. Yes.
Why does water loosen them?
Why does water loosen them? So not in the course, but it is because, it's quite complicated, but it's because the bond between the sodium ion and the water molecule is actually stronger than the bond between the sodium ion and the chloride ion. Not in the course, but the bond it forms with the water is stronger than the bond it has with chloride. Okay? Which you will do in chemistry next year. Samuel.
How come when you evaporate water, salt is left at the bottom if the ions are...
So if you take the water away, then you're just left with this and this, aren't you? So then this is no longer bonded to the water because there isn't any water. So what's it going to bond with? Yes, so it goes back this way if you evaporate water. Okay, any other questions at this time? Okay. One thing we do in chemistry is we quite often write dissolved sodium chloride, for example, like this, right? You've seen me do that lots and lots of times, haven't you? We write it as sodium chloride but aqueous. Now that's a little bit misleading. It makes you think that they are bonded together. They're actually not, okay? What this means is this. So anytime I write an ionic substance, aqueous, you don't have your anion and your cation bonded together. They're separated, they're floating around separately. This is the actually what we've got going on. Okay? So just be aware of that we use this notation a lot, but it doesn't mean that the sodium and the chloride are bonded together. Okay, let's continue. This is quite fun, precipitation. Now, we've already talked about solubility and insolubility. All right, now, in this course, we assume that substances are either 100% soluble or 0% soluble, effectively. So we look at it really black and white. Okay, so these ones are and these ones aren't, and that's how we look at it. In reality, of course, it's more of a grey scale. Some substances are more soluble than other substances, like they might dissolve only if the water's a higher temperature, or they might dissolve only a little bit so that you can only put a little bit in the water. Like, you know how if you put salt in, if you keep dissolving salt in water, I don't know if you've ever tried this, there is a point at which you can't dissolve any more salt, so it reaches its saturation point. Okay, and so more soluble substances have a higher saturation point. You can put more in and they'll continue to dissolve before it stops. So just be aware that in actual fact it is a grey scale, but for the purpose of this course, we look at it really black and white. These dissolve and these don't, and that's it. Okay? Okie dokie. This is on your formula sheet and it is the solubility table. And this is how we figure out what is soluble and what isn't. Okay? To decide if something's soluble or not, we consult the solubility table and it tells us. So if I were to say to you, is calcium hydroxide soluble? You could look at your solubility table and tell me. And the way you would do it is you could go, okay, well, she's saying a hydroxide. So we go down and look at the hydroxides. So hydroxides are insoluble, but there are these exceptions. So it's insoluble except these ones. So is calcium hydroxide an exception? No. So is calcium hydroxide soluble? No. So will calcium hydroxide form a precipitate? Yes, because that's the solid, which means insoluble. Precipitate means insoluble. Okay? So that's how you use the solubility table, and that's what we're going to practice. Some things that are handy to remember, sodium, potassium, ammonium, and lithium are always soluble. So the first group of the periodic table, lithium, sodium, potassium, rubidium, whatever, those will always form soluble compounds. Okay? Is everybody listening? Okay. I'm just plugging this in because I'm running out of battery. Okay, so they're always going to be soluble. Ammonium's the other one, which is NH4+. Okay, and that's on your formula sheet on the solubility table as well. So, like you can see, ammonium, is it there? Oh, it's there. It should be in all of them, really, shouldn't it?
That's why I think
NH4 should be in the bottom one too. So ammonium's always insoluble. Anyway, ammonium's NH4. It should be in the bottom one.
I believe.
Okay. Anyway, the other thing that's worth remembering is of the anions, which ones are always, regardless of what they're combined with, always soluble, is these two at the top. And that's easy to remember because it says it right there. Acetates and nitrates are always soluble. Okay? No matter what metal you put with them. So I'm going back and forth a bit because I just like to look at the solubility table. Okay, are we happy? All right. Here we go. Finding the chemical formula for these and deciding whether they're soluble or insoluble. To do this, you need your formula sheet. So if you haven't already, find your formula sheet. And firstly, we'll need this table. Remember this one? Formula sheet. You're on your formula sheet? Okay. All right. So this first one here, now we're going back a little bit as to how to find the formula for ionic compounds. Right, we did this at the start of the year, remember? Is everybody paying attention? I really want you guys to learn this and not just not learn it. Okay. Shh.
Sorry.
Good. Barium chloride is the first one, okay? So we go to our formula sheet. First thing we do is we find the formula for barium chloride. Barium is there. It's a 2+, isn't it? It says Ba2+. And chloride is Cl-. Okay, so I know that's Ba2+ as an ion, and chloride is Cl- as an ion. Do you remember how to combine them into a chemical formula? Yep, so we put them together, BaCl. The one, yeah, you swap them, okay, because Barium's got a 2 plus, so you need 2 chlorines to neutralise that, don't you? You need 2 negatives to neutralise that, so you're going to need 2 chlorines. But effectively, you're just swapping the numbers. If barium's got the 2, then you give the 2 to the chlorine when you do the chemical formula. Chlorine had a 1, so barium has a 1, which of course you don't need to write. Yeah? So that's the chemical formula. Now, is it soluble or insoluble in water? So we look now at the solubility table, and it's a chloride. So we look for chlorides. Now, chlorides are all soluble except for silver chloride and lead chloride. So, what about barium chloride? Soluble. Are you getting the hang of it?
Yeah.
Okay, cool. Next one, aluminium phosphate. So again, we go back and we find it. Aluminium is Al3+, according to the formula sheet. And phosphate, we've got to look for phosphate, making sure we're not getting it mixed up with phosphide or something else. Phosphate is there, PO4 3-. Now, putting them together, remember if the charge is the same, then they neutralise each other perfectly. You only need one of each. That 3+ is going to cancel out that 3-. Yeah? So because they have the same charge, except one's positive, one's negative, you just need one of each. We get a 1-to-1 ratio. So no numbers are required. Okay? Now we need to decide if it's soluble or insoluble. So we look for phosphates on the solubility table. Phosphates are insoluble except for lithium, sodium, potassium, rubidium, and ammonium. So what about aluminium? It is insoluble, okay, because it's not one of the exceptions. Make sense? Okay, calcium iodide. So back to this one. Calcium is Ca2+. What's iodide? Iodide is 1- there. So we're going to need 2 iodides, aren't we, to balance out the 2+ from calcium. So we get CaI2. Okay? And who's already checked the solubility? Iodides are all soluble except for silver and lead. We don't have silver or lead, we've got calcium, so it must be soluble. Do you agree? Silver chloride. If you check the table, you'll get Ag+ and Cl-. Do you believe me?
Yes. Yep.
Okay, so 1-to-1, they've got the same charge, so it's just AgCl. Okay, so silver chloride, soluble or insoluble? It's a chloride. Yep, all chlorides are soluble except one of the exceptions is silver chloride. So therefore, silver chloride must be insoluble. Okay, potassium carbonate, that's K+, and I think CO3 2-, which you would get by checking the page. So that becomes K2CO3. And potassium carbonate, carbonates are insoluble. Is potassium carbonate one of the exceptions?
Yeah.
Yes. So therefore it is fantastic. Iron 3 hydroxide. If it's iron 3, it's got to be Fe3+. Hydroxide is OH-. If you don't know that, that's fine because you've got that page there to help you. So putting those together, we get FeOH3. And then we check the solubility. So hydroxides are insoluble. Is iron hydroxide one of our exceptions? No. So therefore it is insoluble. It's actually rust. You know how rust is solid? It's iron Shh. Now that we know how to identify what is insoluble and what is soluble, we can figure out if we're going to get a precipitate forming when we mix together different solutions. Okay? So, mixing together different things, is there a way we can get something insoluble? All right, so let's please have a look at this. Let's have a look at the first question, actually. A solution is prepared by dissolving and mixing sodium sulfate and iron 3 nitrate. Sodium sulfate is Na2SO4. You know how to find that on your formula sheet, right? If I hadn't just told you what it was. Yeah. Iron 3 nitrate is FeNO3. What ions are present in this mixed solution? Iron. Oh, sorry, I was confused because I thought you meant ION, not IRON. You know what I mean?
Iron.
Yes, you're right. We're going to get iron from the iron 3 nitrate. So we're going to get Fe3 plus present in the mixed solution. What else is present in the mixed solution? Sodium. Another. Yes. Not just the cations, but the anions as well. Nitrate. So what's the last one? Sulfate. Shh. Okay. So to get those 4 ions floating around in solution, I mixed sodium sulfate and iron 3 nitrate. If I wanted to get the exact same combinations of ions in solution, what other 2 solutions could I mix together to get the same result?
Maybe sodium nitrate and iron sulfate.
Perfect, exactly. Sodium nitrate and iron sulfate. Okay, so we just swap them. Sodium nitrate, that's going to give us sodium ions and nitrate ions. The other thing we want is iron ions and sulfate ions. So, iron sulfate. Does that make sense? We've just swapped them. So it's the same, all the same ions, but we put them with the other, we put the cation with the other anion. Are you pleased? Do you want to bet money on it? Because you're wrong. I don't know who that is.
He's just this chemistry man.
Now, how far can I go? Can we do one more example, please?
What should I say?
Yes. Charlotte, what page is this question on? 25. Page 25? One more question, and then I'll let you do some problems. All right? Or is it page 24? Oh, but that's just information that I'm going to teach you anyway, and not yet. Yeah. Okay. Using the solubility table, what are 2 possible solutions you could mix in order to form a precipitate of nickel 2 hydroxide? So we want to mix 2 things together. We want one of those things to have nickel in it, and we want the other thing to have hydroxide, so that when we mix them together in the solution, the nickel can find the hydroxide. All right? Are you watching carefully? What's on your computer? All right. You got me there. All right. Excuse me. What charge does nickel form? Is it 2 plus? That I believe you. Oh, there's a 2 there. Oh my god, I'm such an idiot. Okay, so we're going to get nickel something, right? Nickel 2 plus. Actually, I'm going to get rid of the 2 plus. we've got nickel something. There's some sort of anion there. And the other thing we want is hydroxide, OH. Something hydroxide, some sort of cation's got to go there. All right? What's going to happen, right, when we mix these two things together, we're going to have the 4 ions floating around in solution, but because nickel hydroxide itself is insoluble, the nickel ions are going to find the hydroxide ions and they're going to bond, and that's going to form a nickel hydroxide precipitate. Does that make sense? So they're going to separate from their anions and cations in the water. They're going to dissolve, and then they're going to come together to form a nickel hydroxide precipitate. Yep.
Oh, I was just wondering, would something like lithium hydroxide and nickel sulfate work?
So probably, definitely the first one. The second one I have to check. So what you want to do, the criteria, you just want to make sure that what you're mixing together, that both of those compounds themselves are actually soluble, so that they're not already solids. Because if they're already solids, then they might not dissolve or separate to then form a precipitate with the nickel hydroxide. Okay, so you want to choose 2 things that are soluble. So 2 possible solutions. Make sure the ones you choose are soluble themselves. One has to have hydroxide, one has to have nickel. So Toby, you suggested lithium hydroxide.
Yep.
So we've gone lithium hydroxide. So the way to check is to look at your solubility table. Hydroxides are insoluble, so you can't just pick any. You've got to pick one of the ones that's soluble. And these ones listed here are soluble. So lithium hydroxide is a safe choice. Okay, now we do the same thing with the nickel. We need to choose nickel something. It has to be something soluble. So it is safest to choose from the, to choose one of the top 6 generally, because they're the ones that are usually soluble, and then just make sure that the metal that you're working with isn't an exception. So you said sulfate, Toby?
Yeah.
Which is safe because nickel sulfate is soluble. We could also have nickel iodide, nickel bromide, nickel chloride, nickel nitrate, and nickel acetate or ethanoate. If you can't be bothered checking the solubility table, just choose nitrate because it's always soluble. Okay? All right, but let's go sulfate. Okay, mixing those 2 things together, they're both soluble. So therefore, they will split apart in solution, leaving the hydroxide to bond with the nickel and form a precipitate. Next one, silver bromide. All right, so I need silver something and something bromide, don't I? So that I can get silver bromide. So silver, I need silver something that is soluble. What can I put silver with that it's going to be soluble with? Nitrate, good. Silver nitrate. What do we know about silver nitrate? What happens if you get it on you? Yes, good. Okay, next, bromide. What is something that is soluble with bromide? Potassium. All potassium compounds are soluble because it's in group 1 of the periodic table. So those things are both soluble. So when we mix them together, they will separate into 4 different ions, which enables the silver and the bromide to find each other and bond, forming a solid. Okay?